This is question number 5 from P4, paper 4, for the year 2021, January. Question number 5, the question says, using the substitution, u is equal to 3 plus root of 2x minus 1, find the exact value of, so we need to find the exact value of this, but with using the substitution, giving your answer in the form of P, which we need to find, plus Q into ln 2. So our answer has to be in the form of ln 2, where P and Q are integers to be found. So the first thing in the question which we need to notice is that we need to substitute here. What do we need to substitute? So wherever we see 3 plus root of 2x minus 1, we need to put a u in place of it. So I see the 3 plus root of 2x minus 1, and I'm going to substitute u for this. So that's the first step I'm going to do. I have integrate 4 divided by u. And I just write the dx here. Now, when I integrate and I have changed my variable, which was earlier x, to u, I need to change the limits also. Now, how do I change the limits? I have been given an equation to calculate u. So now, earlier my variable was x. So these limits 13 and 1 were with respect to x. But now my variable is u. So the limits have to be in terms of u. For example, u1 and u2. So we have the formula for calculation of u, which is this one. We can calculate, so for the upper limit, I'll call it u1. I have 3 plus square root of 2 into 13 minus 1. So that is 3 plus 13 2s are 26 minus 1, 25. So that is 5 plus 3, which is 8. So the upper limit here is 8. Likewise, we can calculate the lower limit, which we can call as u2. We have 3 plus square root of, and this time for x, we will substitute 1. Okay, for x, we will substitute 1. So we have 3 plus 2 into 1 minus 1. And that will give us 3 plus 2 minus 1, 1. And that is 3 plus 1, which is 4. So I've got my substitution. Now when I have, I had a dx here when my variable was x, but I need to have a du here when my variable is u. So I'm just going to multiply this by du. And just to cancel off the du that I just multiplied with, I'm going to divide by du. So now I have, in all this process, I have dx by du here, which means I have to differentiate x with respect to u. For that, I need to make x the subject of formula. So I take this down. I have u is equal to 3 plus square root of 2x minus 1. So in order to make x the subject, I subtract 3. So I have 2x minus 1. Now I can square both the sides. When I square both the sides, I have u squared minus 6x plus 9 is equal to 2x minus 1. Then u squared minus 6x plus 9 plus 1 is equal to 2x. Therefore, I have u squared minus 6x plus 10 is equal to 2x. Now I can make x the subject by dividing the left side by 2. So I have half u squared minus 6u divided by 2 plus 10 divided by 2. I have to write clearly here u So I'll just correct that. Okay, so now I have half u squared minus 3u plus 5, and that is equal to x. Now I need to find what is my dx by du. Dx by du is change in x as u changes. For that we need to differentiate what we have here. So when we differentiate, we have 2 into half, which gives us 1. We reduce the power by 1, so we have u to the 1, or just u, minus 3. And that is my dx by du. Now I can just go ahead and replace the value of dx by du at this point here. So I have between the limits 4 to 8, 4 divided by u into u minus 3 with respect to u. Now 4 is a constant, we can remove it out, and we can write this as u minus 3 divided by u with respect to u. So now I have 4 and u divided by u minus 3 divided by u. We write it as separate fractions. So that in turn is 1 minus 3 divided by u with respect to u. Now we come to the integration part. So it's after all of this that we will start with the integration, because now we are ready for the integration. So when we integrate, we add 1 to the power and divide by the new power. So we have here u, and now for this 3 divided by u, this is same as 3 into u to the power of negative 1. So when I add 1 to the power, it will be plus 1, and it will make it u to the power of 0, which will make 3 into 0. U to the power of 0, which will make it 1, so 3 into 1, which doesn't make any sense. So what we are going to do here is, we will, when we have this type of case where we integrate and the power of the variable becomes 0, we take ln of modulus of u. Okay, so with respect to u, now we can start putting the start working out with the limits, as we have already integrated here. So we will not put this sign here, so we need to write it between the limits 4 to 8. All right, this is because we already integrated it, so we don't need the integral sign anymore. Now we do the subtraction by plugging in the value of our limits. So we have 4, and u will be substituted by 8 in the first place. 8 minus 3 into ln 8, and I'll remove this bracket from here. All right, and then subtract. Now 4 will substitute for u, 4 minus 3 ln, and modulus of 4. So this is 4 into 8 minus 3 ln 8, because 8 is positive, so we can just write it as ln 8 minus 4 into 4 minus 3 ln 3. Now we can open out the brackets. So we have 8 minus 3 ln 8 minus 4 plus 3 ln 4. 4 is here. 3 ln 4. Okay, we can simplify by subtracting this. So we'll just clean that up. We have 4 into 4 minus 3 ln 8 plus 3 ln 4. Now, if we remember when we were reading the question in the first place, we were told that we need to have the answer in the form of ln2. So we just need to rewrite 8 as 2 cube and 4 as 2 squared. 4 minus 3 ln 2 cube plus 3 ln 2 squared. So 4 into 4 minus, we know that the power goes behind and multiplies with the coefficient in log. So 3 3s are 9, 9 ln 2 minus 9 ln 2 plus 2 3s are 6 ln 2. So we have, now we can simplify minus 9 ln 2 plus 6 ln 2, and that gives us 4 into 4 minus 3 ln 2. Now we can just multiply the 4. 4 4s are 16 minus 4 3s are 12 ln 2. And that is the final answer. We can cross check by finding on calculator this value and substituting, writing exactly this on the calculator and checking whether our answers match. But we have to show each bit of our working, as answer by direct calculator use will not be acceptable.